Cats changed first. Then people began losing control of their own bodies. Some could no longer walk normally. Some lost speech. Others slowly lost their vision. And nobody understood why. The poison had no smell, no warning color, no visible sign that danger was already moving through the town. In the early 1950s, the coastal city of Minamata in Japan depended heavily on the sea. Fishing supported families. Seafood was part of everyday life. The ocean was not simply scenery, it was survival. Every morning, fishing boats crossed the bay before sunrise. Markets filled with fresh fish. Families gathered around meals taken directly from nearby waters. And overlooking the town stood a large chemical factory. For years, industrial wastewater flowed quietly into Minamata Bay. At the time, very few people imagined industrial contamination could silently move through an ecosystem and eventually return through the food people ate every day. At first, the strange events seemed isolated. Residents began noticing unusual animal behavior. Birds appeared disoriented. Fish floated strangely near the surface. And cats behaved in ways people could not explain. Some reportedly stumbled in circles. Others twitched violently or behaved erratically before collapsing. Locals eventually gave the phenomenon a disturbing nickname, dancing cat disease. Soon afterward, people began becoming sick. The symptoms were unlike anything most local physicians had seen before. Patients developed numbness in their hands and feet. Some struggled to hold objects steadily. Others developed slurred speech. Walking became difficult. Coordination deteriorated. Vision narrowed into tunnel vision. Then in severe cases came tremors, paralysis, and convulsions. Entire families were affected. Because the illness developed gradually, many didn't initially realize how serious the situation was becoming. Doctors became increasingly confused. This did not behave like infection. It did not spread from person to person through coughing or direct contact. And yet new cases continued appearing. The mystery deepened as investigators noticed patterns. The worst cases clustered around fishing communities near the bay. Families who consumed large amounts of local seafood appeared especially vulnerable. Now, suspicion slowly shifted toward the environment itself. Something in the bay was poisoning the town. But investigators still did not know exactly what it was. As more patients appeared, hospitals became overwhelmed by uncertainty. Some patients could no longer feed themselves. Others lost the ability to speak clearly. Families watched loved ones deteriorate without understanding the cause. Most terrifying of all, the poison remained invisible. The water looked normal. The fish looked normal, and life continued nevertheless. Researchers began studying the local ecosystem more closely. Eventually, scientific investigation identified the substance responsible. Methylmercury, a highly toxic organic form of mercury capable of causing severe neurological damage. Unlike some toxins that remain outside the nervous system, methylmercury can cross into the brain. It can also cross the placenta during pregnancy, exposing unborn children during critical stages of development. But understanding how the toxin moved through the environment was equally important. The contamination did not simply remain in the water. Small aquatic organisms absorbed it first. Tiny creatures near the bottom of the food chain accumulated the mercury from contaminated sediments and water. Then small fish consumed those organisms. Larger fish consumed smaller fish. And at each step, the concentration increased. A process known as biomagnification. Instead of becoming diluted, the toxin became more concentrated higher in the food chain. By the time seafood reached human dinner tables, the contamination levels had become far more dangerous. The poison had silently traveled through the entire ecosystem, and because seafood was an important part of local diets, exposure became widespread. As investigators continued tracing the source, attention increasingly focused on the nearby chemical factory operated by Chiso Corporation. For years, industrial wastewater from chemical manufacturing processes had been discharged into Minamata Bay. During production, mercury compounds were released into the environment. Inside the aquatic ecosystem, those compounds transformed into methylmercury, the highly toxic form that accumulated in marine life. Now, the scientific picture was becoming clearer. The sea itself had become contaminated, and the contamination had entered the human nervous system through food. But scientific discovery did not immediately end the disaster. Recognition unfolded slowly. And for many families, it came far too late. Some victims had already suffered irreversible neurological damage. Others faced permanent disability. Children born with congenital Minamata disease experienced devastating developmental and neurological injuries. Some struggled with movement, coordination, speech, and cognitive function throughout their lives. The emotional impact on families became enormous. Fishing communities faced social stigma and economic collapse. Many residents depended on the sea not only for food, but also for income. Now the same waters that had sustained generations were associated with fear and illness. And because the contamination had spread gradually over years, the full scale of the disaster took time to emerge. This slow unfolding made Minamata especially terrifying. There was no explosion, no visible cloud, no immediate warning siren. The poisoning spread silently through ordinary life itself, through meals, through fishing, through daily routines that once felt completely safe. The disaster also raised difficult questions about industrial responsibility and public health response. As evidence accumulated, debates intensified over accountability, recognition of victims, compensation, and environmental regulation. Investigators, physicians, journalists, and affected families helped bring global attention to the crisis. And the world slowly began recognizing Minamata disease as one of the most important environmental toxicology disasters in modern history. The lessons extended far beyond one coastal town. Minamata demonstrated how industrial contaminants can silently move through ecosystems and eventually enter the human body. It revealed the dangers of bioaccumulation and biomagnification within food chains. And it showed how environmental exposure can sometimes remain hidden until widespread harm has already occurred. The disaster also transformed global understanding of mercury toxicity. Researchers learned more about how methylmercury affects the nervous system, how it damages coordination, sensation, vision, hearing, and cognitive function, and how developing fetal brains are especially vulnerable to toxic exposure. Over time, Minamata became a symbol of environmental awareness and industrial accountability. Its impact influenced public health policy, environmental monitoring, and toxicology research around the world. But even decades later, the emotional weight of the story remains powerful, because the tragedy did not arrive through dramatic destruction. It arrived quietly. Today, Minamata remains one of history's clearest warnings about environmental contamination and invisible toxic exposure. A reminder that some of the most dangerous disasters are not always explosions or fires. Sometimes they spread silently through water, food, and biology itself. And by the time people finally recognized the threat, the poison may already be inside the next generation. Follow for more investigations into toxicology, environmental disasters, medicine, and the hidden dangers that shape human survival. This video is an educational cinematic reconstruction based on documented historical events, scientific literature, and environmental toxicology research related to Minamata disease. Some scenes are dramatized for storytelling purposes and are not exact visual recreations of real individuals or events. The content is intended solely for public education, historical awareness, and discussion of environmental health and toxic exposure.